Did you ever take banned substances to enhance your cycling performance?
Yes.
Did you ever blood dope or use blood transfusions to enhance your cycling performance?
Yes.
Shut up, Lex.
Hey guys, this is Faster U4, brought to you by FitLab, Tailwind Nutrition, Biomax and Capital Cycles. If you're a cyclist and you want to go faster, then let's giddy up.
Don't stand on my dog or I cut your head off. Say hello.
Hey guys, so here we go. I wanted to do a test today, and I did. So I went up a hill, took some data, and I think you're going to be interested in the results. So what got me thinking here was I was just listening to the latest Cycling Tips podcast, and it got me pissed off because it says the title is your power meter as accurate as you think? And so they had a panel of guys. One guy talking from a power meter manufacturer called Infocrank. One of them was from Stages, and the other guy was a coach, I think. And so the guts of it was that there were most of the conversation was centered around how do you know if your power meter is accurate? And this question kept coming up over and over again. The question was around this advertising talking point for power meter manufacturers, where they always say, well, you know, they're accurate to within 1 or 2%. And the question that the Cycling Tips interviewer was trying to get answered was, well, 1 to 2% of what? You know, is it 1 to 2% of some gold standard? That question kept coming up, and it was just, to me, really annoying. To either what was going on was the power guys who were representing the power meter manufacturers, the Stages guy and the Infocrank guy, weren't wanting to answer the question, or they weren't listening. But the question was pretty basic. It got boiled down to, is there a gold standard for determining whether a power meter is accurate? Now, of course, you can, there is, and it was somewhat addressed by when they said you could use a dynamometer in a lab, and that's fine. That would be one way to do it. The other way I kept thinking, which none of them brought up, was actually just to do a real world test. Now, I know that in the real world there's problems mainly with determining all of the factors around, controlling for all the factors and the ones that come up, in any real world test like this are always going to be wind, coefficient rolling resistance on the road, humidity and levels and all that, air pressure. Well, there is actually an online resource to do exactly this, a reasonably sophisticated model where you can do a hill climb, you can control for all those variables, and it's pretty simple math to determine, of course, in X amount of meters climbed, in X amount of time, Y amount of time, whatever, X's and Y's all over the shop, where you the amount of power required for doing that work. And it's this guy, von Wolfgang Men. Good on you, von Wolfgang. You put together a good model here. And I've gone ahead and this morning I've gone out on my bike. I took some footage. I went up a local climb here. I chose today because there's no wind. It's quite a steep climb, so that fudges out wind factor even further. And the road surface is a standard. I wouldn't say coarse chip, but it's got a really close rolling resistance to the 0.005 model in this calculator. So it's an ideal road to use. So it's a stretch here, 1.7 k's long exactly. It has a rise of, here we go. It has a rise of 147 meters. So to get from the top to the bottom of that in X time, you need this power. I've gone and put it into the calculators here and worked it out, and I actually went and did it. And I also, just to add spice to this, did it on 2 different power meters. So just to restate. So the goal of this was to determine, using 2 power meters I've got, a Quark D0 and a power tap SL. So I wanted to hook both of those up to different devices, which I did. Collect the data for that hill climb and compare that to a gold standard, which is the calculations that this guy has done, so that we can determine if the power meters, how close the power meters are to each other, but also to an objective standard. So let's find out. So here is here's hill climb 1. I did the hill twice. The reason I did it twice was because I wanted to get two measurements for the same climb, but also but in the second climb I did some accelerations I could get some information about the macro data, like a long climb, long term, about 7 or 8 minute climb, and the micro data that they were referring to on the podcast, which is, shorter term power bursts of, in my case, 30 seconds and 5 seconds and a minute respectively. I'll cover that later on, but for today we'll just stick to the basic question. So first hill climb here is here. So I've highlighted exactly the points so we know exactly what we're talking about, so that I compare exactly. So this is the power taps data. Okay, so in this hill climb here, we've got an average power. We won't talk about normalized power, we're talking average power output there, 296 watts. Okay, 296 watts measured on the power tap. So let's see how that did against an objective measurement of a gold standard objective measurement, whether that is accurate or not. So 296 watts, I've gone and done the math here for you. 200 and the gold standard for this, 293.1. So just to reiterate, power tap said 296. Wolfgang said 293.1. So we are within 3 watts. 3 watts, just under 300 watts. Just under 3 watts at just under 300 watts. We're talking 1%. So the power tap's within 1%. Let's see how the Quark did. 299 watts. And so power tap 296, Quark 299, and Wolfgang 293. So the Quark was out. Power tap 296. Sorry, power tap so was out by 3 watts. The Quark was out by another 3 watts on top of that, by 6 watts. So that's pretty good. So that another 3 watts. That's we're going to call that 2%. So the power tap for test 1 was within 1%, and the Quark was within 2%. And that actually fits with, if you take the definition of power meter manufacturers saying that their power meters are within 1 to 2%, well, if you're saying the definition is 1 to 2% of an objective standard, well, in this case, that is exactly right. Bang on. It was kind of annoying listening in the podcast. There was this Australian guy representing the InfoCrank guys, and he did a lot of talking around, using terms like saying, oh, well, a lot of power meters, they're completely useless and their information is completely useless. And when he was asked to drill a little bit more down into why it was completely useless, he was talking about very, very small spikes in power and how accurately that would be measured. Now, that may be true, and I'll do that in a future test. I've got the data. Well, I'll do that when I pass out the data from that. But just for today, I think he was pushing it from the perspective of someone who wanted to sell a very accurate system for short-term bursts, and maybe it is. I haven't tested that here, but for any hill climb like this, those power meters are highly accurate. Okay, so let's go to test 2. This is exactly the same down to the meter. Test sector there. And I'll just go 1 pixel over just to make it perfect. There we go. Boom. It's pretty much exactly on the same money. So this second time I climbed it, the power was a little higher, but it doesn't matter. I've still gone and done the math here for you. Okay, this is the power tap. It's telling me 328 watts for this second climb. Wolfgang, 320.9. Let's just call that 321 for the sake of 0.1 watts. So power tap says 328. Wolfgang says 321. Again, that is very close. That's within the 2%. So let's see what Quark says. Second time around, Quark says 324. Wolfgang says 321. So the Quark that time was actually closer than the power tap and was within 3 watts. 321. What did I say? 321 versus 324. And of course that's actually that doesn't have any decimal places. So that's within 3 watts. So that's, in that case, the Quark was actually marginally more accurate. For that second test. So test 2, Quark, so power tap within 328 watts versus, so within 7 watts, Quark within 3 watts. That's within the 2%. So let's just reiterate what we were trying to find out here was how accurate this was. Oh, and I just want to sort of put your mind to rest about a couple of things here. In this calculator here, I did weigh myself and all my gear, including the water bottle, everything, to make sure that the weight of the total system was accurate. It was 92.8 kilos. And the times here are listed down to the second. He even breaks it down here. You can see power due to the hill climbing. He's even got the air resistance accounted for there. 12 watts for air resistance, 285.8 watts for the hill climb itself. Rolling resistance accounted for 16.6 watts. And that's how you come to your final total here, accounting for drivetrain efficiency. So it's accounted for. So I think, in a lot of, okay, so this represents a study into, macro power in the real world. And like, I think, we can say for 2 hill climbs there, wind is taken out of the equation because there's no wind. The aim of this was to test in a condition where you're doing a relatively steep hill climb, 7 to 8 minutes worth, how valid the data was between the stages, between the Quark and the power tap, and they were both within 1 to 2% of each other, and they were also within the big question: is there a gold standard? Yes, there is. Were they within 1 to 2% of it? Yes, they were. So yep, tick on both levels between comparison and gold standard. Tick for both of those power meters. So so that's good to know. So next, what I'm going to do is do some research, some passing out into these little accelerations here, these 5-second bursts to represent a piece of microdata, and the 1-minute burst here at 400 watts. I've got all the data for that collected from both those power meters, and in the next video I'll tell you if they were accurate or not. Alright, thanks for watching. Thanks for watching / listening to Fast You Fall, brought to you by FitLab, Capital Cycles, Tailwind Nutrition and Biomaxa. If you'd like to get in touch for a coaching program or testing, you can get hold of me, Steve at fitlab.co.nz, or go to fitlab.co.nz. Talk soon, guys.